Now let's take a look at the second example in section 5.2 where we are asked again to verify the identity, but this time it's a little bit more complicated looking than the previous case. Here we have 2 times the secant squared of alpha equals 1 over 1 minus sine of alpha plus 1 over 1 plus the sine of alpha. So in this situation, the right side of our equation is a little bit more complex looking, so that's the side we're going to go ahead and try to manipulate. So this is the side that I have chosen to work with. So as again, the previous example, we had to choose a side first. I'm going to write down that that's the side we are choosing this time around, and that's the side that we're going to manipulate. So step number 2 is to just go ahead and rewrite and rearrange. So we have 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. Now we want to do whatever we can to make this entire expression, whatever it was that was given to us right here, turn into the less complicated side of the original equation that was given. So we want to change this entire fractional expression into 2 times the secant squared of alpha. So one of the ways we could do this is just first off, try to combine it into one common, one large term. And the only way we can really do that is by finding the common denominator, which would be the product of the 2 denominators here. So we're going to do 1 minus sine alpha times 1 plus sine alpha, which means that from the individual numerators, the first numerator was missing this term. So that's going to be multiplied here by 1 plus sine of alpha. And in the other case, on the right fraction, this one is missing a factor of 1 minus sine alpha because now it has this denominator added into it from right here. So the numerator changes and it becomes 1 plus sine alpha, that's the pink part, plus 1 minus sine alpha. So now we have one single fraction, slightly larger than the previous combination of fractions, but that's okay. Because in the numerator, sine alpha here cancels with sine alpha here because there's a positive and a negative of both of them, whereas the ones both add up. So that's going to give you just a 2 in the numerator. And if you FOIL the denominator that you have here, so just multiply out all the individual terms, you're going to end up with 1 minus sine squared of alpha. Now, going back to the Pythagorean identities once again, 1 minus the sine squared of alpha is equal to cosine squared of alpha. So that's going to be replacing our denominator. So this is going to come in as cosine squared alpha in our next step. So now we have 2 over cosine squared alpha. But of course, if we have a cosine squared of alpha in the denominator, or even just the regular cosine of alpha in the denominator, you could use the reciprocal identity and bring it up to the numerator as the secant. So that's going to become 2 times the secant squared of alpha. And if we go back to the original problem here, we've taken the right side of our equation, the complicated side, and we have changed it into the left side of the equation, the less complicated side. So now we can go ahead and say that this is in fact equal to the left-hand side of our problem, which means we have verified that identity.